Right, grade 12s, we're going now to be looking at the cubic function or the cubic polynomial, factorizing it and using long division and the synthetic method. So this topic is very fundamental and important when we are going to be doing functions in grade 12. You need to master how to factorize a cubic function or a cubic polynomial. Okay. So by the end of this lesson, you should be able to show understanding of steps for doing long division on polynomials, and also you should be able to show understanding of steps for doing synthetic division method on a polynomial, and also use the remainder and factor theorems to factorize a cubic polynomial or a cubic function. Right, let's look at long division of a polynomial. So this is just like long division of your real numbers, all right? Your numbers which you are dealing with. It's only this time you'll be dealing with polynomial. So if you've got a binomial dividing a quadnomial, which is a cubic function here, the cubic polynomial, we are going to say step 1, you divide the first term of the binomial or a divisor. You divide the first term of the dividend, so which is the quadnomial under the division sign. You divide x to the power of 3 divided by x, x being the first term of the binomial divisor. So you get your answer x squared, you put it on top, and then step 2, you multiply the quotient, which is x squared, multiplying the divisor, binomial x minus 4, and then you get your product. And then you take this product, you put it beneath your dividend, right? And then you subtract the resulting x to the power of 3 minus 4x squared from your dividend. And then you are going to see that you get your answer being equal to negative 10x squared. All right, and then you write it down there, and then you bring down 49x and negative 36. Right, you bring them down, and then you say again negative 10x squared divided by x. You write your answer on the next to x squared, which is going to be negative 10x, and then you multiply negative 10x, multiplying x minus 4, and then you get your answer, which is negative 10x squared plus 4, which is plus 40x, and then you subtract it, which is going to be, you get your answer, which is going to be a 9x, and then you subtract, you put your 9x, you bring down negative 36, sorry, and then you say again 9x divided by x, which gives you a positive 9, and you multiply 9 multiplied by x minus 4, you get 9x minus 36, and then you subtract again. You see that the remainder in this case is going to be 0. So you have finished dividing, right? You will see later on what this means. So you are going to say now x cubed minus 14x squared plus 49x minus 36 will be equals to x minus 4 multiplied by x squared minus 10x plus 9. So in other words, we factorize. You see that I have not completely factorized because that is another objective of this lesson. Now, this is how you use the long division method. Remember, you divide, right? You get the answer, you multiply, and then you subtract. You repeat again. Divide, multiply, subtract. Divide, multiply, subtract, and you continue like that until you reach the end where there will be nothing or there will be a number remaining there. So in this case, we say that the remainder of this division was a 0. Let's use the synthetic method on the same sum to see if we arrive at the same answer. So the synthetic method, this one I know that a lot of grade 12s, they like it because it's faster. We are going to say x to the power of 3 minus 14x squared plus 49x minus 36 divided by x minus 4. So we take the factor x minus 4, we equate it to 0, and then we solve for x, which is going to be x is equals to 4. And then we write down, we take the division sign, we write it upside down. Right? Right? Which is x is equals to 4. And then you take your division sign, right? You invert it. Right? We invert the division, the long division sign, right, like that. And then on the left side, we write our value of the unknown, which is 4 at the top left. And then inside, we take the coefficients of the quadnomial. So the coefficients in this case are going to be, the coefficient of x cubed is 1, coefficient of x squared is negative 14, coefficient of x is 49, and the constant is negative 36. Now what we do is we bring down the 1, and then we say 4 multiplied by 1, which gives us a 4. And then we add negative 14 plus 4. Right? You bring down the 4, we multiply 4 multiplied by 1, which is a 4, and then we say negative 14 plus 4, which gives us a negative 10, and then we say 4 multiplied by negative 10, which gives us a negative 40. All right? And then we add 49 minus 40, which gives us a 9, and then 9 multiplied by 4 is a 36, right? 36 minus 36 plus 36 gives a naught, so there is no remainder. So now the one we got, the first one here, is the coefficient of x squared. So the power now of the quotient is reduced by 1. So it was a cubic function, now it becomes a cubic polynomial. Now it becomes a quadratic polynomial. So our 1 becomes the coefficient of x squared, negative 10 becomes the coefficient of x, and 9 becomes the constant, and the 0 is the remainder, which is nothing. So we rewrite our polynomial as x cubed minus 14x squared plus 49x minus 36 will be equals to x minus 4 multiplying x squared minus 10x plus 9. So please play back the video if you do not see the steps again, so that you understand them. Right, and then you basically choose the one that works for you. I know a lot of you will want to use the synthetic method. Right, so now let's look at the examples. Right, example number 1, they say calculate the remainder of x cubed minus 9x plus 3 divided by x plus 2. You will see I'm going to use both methods, the long division method and the synthetic division method. Right, so using the long division method, I'm going to say x plus 2 dividing into x cubed minus 9x plus 3. We do the same thing. You can see we are saying x cubed divided by x gives you x squared. Then you say x squared multiplied by x, x cubed. X squared multiplied by 2 is 2x squared. And then you subtract your product from the dividend. Right, you get negative 2x squared. You bring down 9x, you bring down plus 3, and then you divide again. 2x squared divided by x gives you negative 2x squared divided by x gives you negative 2x. Then you multiply negative 2x multiplied by x gives you negative 2x squared. And then negative 2x multiplied by 2, it gives you negative 4x. Then you subtract. It's going to give you a negative 5x. You bring down 3. You do it again. Negative 5x divided by x gives you negative 5. Then you say negative 5 multiplied by x gives you negative 5x, and then negative 5 times 2 gives you negative 10. Then you subtract. This time you see there's a remainder, so we write this is remainder 13, and then you write, right, you are going to say now x cubed minus 9x plus 3 is equals to x plus 2 multiplied by x squared minus 2x minus 5. Because there's a remainder, this is a positive remainder, so it's going to be equals to plus, you say x squared, x plus 2 multiplying x squared minus 2x minus 5 close bracket plus 13. Okay, let's use the synthetic method. So with the synthetic method, we take the divisor, we equate it to 0, and we solve for the unknown. In this case, it's going to be -2. Then we write our division sign, right, inverted, and then we put our -2 on the top left side, right, and then we take the coefficients. Note here, we do not have the value of x squared or the term x squared in this polynomial. So we are going to say the coefficient of x cubed is 1 and the coefficient of x squared is 0. Very important, because we don't have that term there, but it's a placeholder. It's a placeholder. So it's going to be 1 coefficient of x cubed and 0 coefficient of x squared and -9 coefficient of x and the constant 3. And then we bring down 1, we multiply -2 multiplied by 1 gives you -2. 0 minus 2, it's going to give us -2. -2 multiplied by -2, it's going to give us +4. -9 plus 4 is going to be -5. And then -5 times -2 is going to be a 10. 3 plus 10 is going to be 13, which means that the last number there, 13, is our remainder. So we're going to say this is x squared minus 2x minus 5, remainder 13. Can you see that? So now we can rewrite, therefore x cubed minus 9x plus 3 will be equals to x plus 2 multiplied by x squared minus 2x minus 5 plus 13. Okay, now let's look at another example. Right, determine the remainder of x cubed minus 27 divided by x minus 3. So we're going to say both, we're going to do both again, long division and synthetic methods. So we take the divisor x minus 3 dividing into x cubed minus 27. We divide x cubed divided by x, it's going to be x squared. We multiply x squared multiplied by x gives us x cubed, multiplied by -3, and then we subtract. So we're going to remain with positive 3x squared. We bring down -27. Then we say 3x squared divided by x, which is going to be plus 3x, right? So that is plus 3x, and then we say 3x multiplying by 3 by x is going to be 3x squared. 3x multiplied by -3 is going to be -9x. Then we subtract, so we're going to remain with 9x minus 27. We bring down the 27, we divide again. 9x divided by x is going to be 9. 9 times x, 9x. 9 times -3 is going to be 27. And then we subtract, the remainder is nothing. So therefore we can say x cubed minus 27 will be equals to x minus 3 and x multiplied by x squared plus 3x plus 9. Right, let's say let's use the synthetic method again. We take our divisor binomial, we equate it to 0, and we solve for x, which is going to be 3, and then we write our division sign inverted, and then we put our 3 on the top left side, and then we bring the coefficients. Again, remember, we have got two terms which are not there. We have got the coefficient of x squared and the coefficient of x. So the coefficient of x cubed is 1. Coefficient of x squared, it's a 0. Coefficient of x, it's a 0. And then we have the constant. Okay. And then now we bring down the 1. And then we say 3 times 1, which gives us a 3. And then 0 plus 3, it gives a 3. And then 3 times 3, it's a 9. 0 plus a 9, it's a 9. 9 times 3 is going to be positive 27. Negative 27 plus 27, it's a naught. So we are going to say now our x squared coefficient is 1, and then 3x plus 9. So we can say therefore x cubed minus 27 is equals to x minus 3 multiplied by x squared plus 3x plus 9. Okay. Now, let's move on and look at something else. Let's look at the remainder theorem. So the remainder theorem is a theorem which we use, which is a faster way of finding the remainder of a polynomial between when you do a division. Rather than having going through the whole process of division, you can do it just faster, substituting the value of the divisor into the polynomial and then seeing if there is a remainder or not. So for example, find a remainder of f of x, which is x cubed minus 3x squared plus 3x plus 2 divided by x minus 1. So we're going to say x minus 1, we equate the divisor to 0 and solve for x. And then we are going to substitute the value of x into f of x. So where there is x, we are going to be putting 1. That's how we find the remainder theorem, the remainder. So we are going to say our f of 1, we substitute where there is x, we put 1. And you can quickly punch that into a calculator. You will see that f at 1 will be equals to 3, meaning that this is, okay, that is another theorem. So you can say in this case, our remainder is equals to 3. So we can do the same, right? If you are given g of x is equals to 2x cubed minus x squared minus 4x plus 3 divided by 2x plus 3. So you get your divisor equated to 0, and so for x, then you, for your remainder, you are going to say g at negative 3 all over 2 will be, where there is x, you put negative 3 all over 2, and then you quickly punch in your calculator, and you will see that the answer is going to be 0. In this case, we have no remainder, or we can say the remainder is 0. So you can see in our two cases, the other one, the remainder is 3, the other one is a remainder is 0. And you can see calculating remainder this way is faster compared to having to go through the whole division process. So what does this remainder theorem work? How does it work when we are dealing with cubic functions? So which takes us to the next theorem, which is the factor theorem. So the factor theorem makes use of the remainder theorem in such a way that when we do the factor theorem and we have got a remainder that is less or greater than 0, then we know that that divisor is not a factor of the dividend polynomial. Are we together? Which means the dividing polynomial is not a factor of the dividend polynomial, right? So again, if your remainder is equal to 0, then we can also conclude that that divisor is a factor, of the dividend polynomial. Then that divisor polynomial is a factor of the dividend polynomial. Very important. Okay. Now, let's do some examples. Right. Let's say they say, right, determine if x plus 4 is a factor of, right, f of x, which is equals to 2x cubed minus x squared minus 4x plus 2. Now we want to find out, is it a factor? So we equate our divisor to 0, and so for x, then we substitute, right, the value of, our divisor into into f of x. So here we are going to be putting negative 4, right? So you punch that into your calculator quickly, you see that your f at negative 4 is 126, meaning that x plus 4 is not a factor of f of x. And then now we use another we're given another function. G of x is equals to x cubed plus 3x squared minus 10x minus 24. Now I want to find out, is x plus 4 a factor? So we substitute again. Where there is x, we are going to be putting g of negative 4. And then we punch that to the calculator. You see that the remainder, g at negative 4, would be equals to 0. This means that x plus 4 is a factor of g of x. So once you have done that, now you can do your division and complete factorization, which is what we are going to be doing next. So the next example, they say, factorize now, which is where we are coming. Factorize the polynomial. Now, example, they say, factorize 2x cubed plus x squared minus 7x minus 6. Now, a lot of people ask me, how do I know which factors to use? So what you do, you look at the first term, you write its factors down. Then you look at the last term, you write its factors down. So if you look at the first term, the possible factors of the first term, we've got 2x, right? 2x squared, 2x cubed. So we are going to be only using 2x, which is a factor to the power of 1 or x. So it's either 2x or x. And then with a combination of the factors of the last term, negative 6. Negative 6 has got factors like negative 2, negative 3, negative 1, negative 6, positive 1, positive 2, positive 3. So you make a combination of those factors, and those are the ones you test to see which ones of those will be factors. So in this case, I have listed the possible factors here. I can use 2x plus 2, I can use 2x minus 2, I can use 2x plus 3, I can use 2x minus 3, I can use 2x plus 6, 2x minus 6, and so forth. The number is endless. So I can test those ones. So using the remainder theorem, I can check which one is a factor. So I choose the first one, 2x plus 2. I solve for x, the value I substitute into the function or into the polynomial, and then I see that gives me a 0, so I don't have to go further. Using the factor theorem, this tells me that 2x plus 2 is a factor. So I'm going now to use, in this particular sum, I'm going to use long division. So using long division, I'm going to say 2x plus 2 dividing into 2x cubed plus x squared minus 7x minus 6. I use my long division method. Remember how to use it. There we go. So I use my long division method, and I find out that since it's a factor, I'm going to just get the factor. So I write 2x cubed plus x squared minus 7x minus 6 will be equals to 2x plus 2 multiplying x squared minus x all over 2 minus 3. And then I factorize the other factor, completely factorize everything. So I'm going to get my, here I'm going to get my x squared is equals to, so the factors will be, so here it's going to be 3 all over 2 and 2 there. So this is positive, this is negative. So there I go, everything completely factorized. Next example, right, factorize g of x is equals to 6x cubed minus 5x squared, right, minus 17 plus 6. Right, I look at the first term and second term, I come up with my factors. I've got a number of them, so I can just list for you. I just use the first term and the last term, and I use a combination of their factors, and then I start checking. Right, so I start doing my test. I take the first term, the first factor, x plus 1, right, I equate it to 0, which gives me x is equals to negative 1. I use remainder theorem, right? Using remainder theorem, I check, is there any remainder, right? So this remainder, you see that is greater than 0. So using factor theorem, that's not a factor. And then I use this next factor, x minus 2, x is equals to 1. I use the remainder theorem. My remainder will be equals to negative 10. So you can see it's less than 0, not a factor. And then I take the next factor, x minus 2 is equals to 0. And then x is equals to 2. I find my g of x. In this case, is going to be equals to 0. So that one is a factor. So now I can use my synthetic method. Synthetic method is going to be x minus 2 is equals to 0. I guess x is equals to 2. I take the coefficients. I find the other product, which is 6x squared plus 7 minus 3. And then I can say my 6x cubed minus 5x minus 17x plus 6, right, will be equals to x minus 2, 6x squared plus 7x minus 3. And then I completely factorize everything. It's going to be 3x, 2x there, minus 1 plus 3. There I go. I have factorized. So that's how you use these tools: long division, synthetic method, remainder theorem, and factor theorem to factorize a cubic function. I hope you have enjoyed it.